It's not usually that loud at these meetings, but it's welcome. It's good to hear. I'm Mark Innebaugh, the leader of this group, co-leader. My other co-leader is Angel Gundas in the back corner. And when we originally scheduled this meeting, it was, I think it was about September of last year. And somehow I just assumed that 4th of July, since it's on a weekend, we're going to have Monday off. And instead, most people get Friday off. So I'm amazed to see so many people here after such a scheduling snafu by me. And welcome to the meeting. I'm going to try to keep the introduction short. I've got a few things I need to hit on, and then we'll get right into the presentation. So this group meets the first Thursday of each month, and we alternate locations between here and San Francisco. We don't meet in August, so there's not a meeting next month. We have sponsors, so SolarWinds, Pyramid Analytics, Microsoft, and DesignMind sponsor this group and allow us to put on the meetings for free. Obviously, you know the Mountain View location here, but the San Francisco location that recently moved, and it's now at 555 California Street, was 835 Market. So you can still get there by BART easily enough. It's not a long walk from BART if you end up commuting that way. This should say July meetings, not June, July, but on Wednesday in San Francisco, we've got Andrew Eichenbaum speaking on big data and data science, how to get past the hype and into the team. And I work with Andrew at DesignMind, and he's given this presentation a couple of times. And what he's trying to do is design or define the different roles that exist within either a big data team and project or data science. And to allow you to maybe look at your skills and say, where would I fit in most easily and what are the gaps in my knowledge? So if you wanted to get into one of those teams, would be an interesting presentation here. And then on Tuesday, July 21st, at this location, Ami Levin, who's the co-leader with me of the Silicon Valley SQL Server User Group, is going to give what he's calling part 2 of a talk on primary keys in that presentation. It's part 2, but I would encourage any of you who are interested in primary keys to attend. And the reason why is he talked about in the first meeting about a bunch of different examples, but it was purely PowerPoint. And what he's going to do in part 2 is he's going to go through actual examples. Yes.
Can I elaborate on how was it that meeting?
Yes.
It was very theoretical, first one. I think he mentioned he was going to do more of a practical approach on the second one.
Yeah. Thank you.
We'll see way in the front.
Yes, there is one right front and center for the brave soul who wants to make their way to the front. Okay, so Sacramento is the people who run the SQL Server User Group in Sacramento are putting on a SQL Saturday on July 25th. This is an all-day free event. I've seen their lineup of speakers, and it's going to be a really interesting event. It's free, and I would encourage you to consider attending. There are also 2 pre-cons, which are a full-day session on the Friday before SQL Saturday. And got 2 top people in their field. Kaylin Delaney on Index Magic is how she's describing it. She's been a SQL Server MVP for 20 straight years. She's written numerous books on the SQL Server data engine, the internals of SQL Server. She's truly an expert. And then the other pre-con is Paul Turley. He works for SolidQ. He speaks, he writes, and consults. And his topic is building a business intelligence solution with Power BI components in Excel 2013. And people at DesignMind are going to be attending that one, people who need to ramp up on that particular topic. We also have the PASS Summit coming up October 27th through 30th. This is the world's largest SQL Server and Microsoft BI conference. It's really an outstanding conference. If you can get your employer to send you, I encourage you to try. The value's there. And if you use the code that's shown at the bottom of the screen here, you get $150 off your registration. PASS has a whole lot of virtual chapters. In this slide, I mean, it's real, all the different virtual chapters they have, but it's too much to absorb. The real message there is that there are these virtual chapters, so you can attend. They usually meet about once a month, and you can attend remotely and just watch for the topics that you want. You can go to SQLpass.org, sign up for a free membership, and you can get on the distribution list to be notified of the topics that are of interest to you to attend virtually. I usually give people a chance to make an announcement. If you're looking for work, if you're trying to hire somebody, if there's an event coming up that would be of interest to people in the room but that I didn't mention, that sort of thing. Are there any announcements this evening? Yes?
So I'm Jose Luis Pacheco. I work at Bridge Bank. I'm the internet developer there. I'm looking for new opportunities. I have the bank has been acquired by another bank, and unfortunately, I'm one of the casualties in it. So I'm looking to see if I can get some.
So you are a
SharePoint developer and administrator. That's my pure background, as well as .NET developer. Thank you.
Centene.com.
Centene.com.
Yeah.
I'll give you my phone. Thank you.
Any other announcements? Okay, so tonight's speaker is James Taylor. I tracked him down because he recently spoke at the PASS Business Analytics Conference in Santa Clara. And I knew he lived locally, and I contacted him, and he was good enough to accept my invitation to speak tonight. He's the CEO of Decision Management Solutions. He's one of the leading experts in decision requirements modeling. And he's leading efforts to use these models for business intelligence requirements. And his topic tonight is a new approach to defining BI requirements. James Taylor.
All right, thank you. All right, so when I first arrived, there were already a few people here. I said, oh, I'll speak quietly and make you all move to the front. Now it's full, so I have to speak at full volume. So as I won't spend a lot more time on introduction, I need to say a couple of things. I have a couple of copies of my books here, which will be given for questions at the end. And questions will exclude things like, can I have the book? How do I get on the one-on-one? I mean, yeah, it has to be a question about the content, okay? But other than that, we'll give the books out. You are, of course, all free to buy as many copies as you like. They're both available on Amazon. I've been doing this a long time. I've been talking about decision management and decisions, and you'll see why that's relevant in a moment, for a long time, for about 12 or 13 years now. I was at FICO, before Fair Isaac. Before that, I have a background in software development, case stores modeling. As you may tell, I have a little bit of an accent left from my time in England. I'm closing in on more time in the US than in England, but not quite there yet. So about halfway. I'm also a faculty member of the International Institute for Analytics, an IBM champion, SAS ambassador, yada, yada, yada. And what I want to do today is talk about a new approach to requirements for analytics, BI, predictive analytics, data mining, any kind of analytic approach. If you're interested in the slides, by the way, I'm happy to send them out as a PDF. My email address, Twitter handle, and stuff on the board there, because I'm out of dead tree versions of my business card. I'm happy to send you the slides if you're interested, just let me know. Anyway, so decisions first requirements. Why am I talking about decisions when it comes to BI? Well, one of the sort of things I do besides working with clients and client companies is some research. And we did some research recently, and we talked to a lot of people about what they do with BI, with analytics, and what they use it for. And what became clear were there were three things people did with BI. They built reports, they did reporting, they monitored things, they tracked how well things were going, and they made decisions. or they help somebody make a decision. Now, these don't map completely to reports and dashboards and other kinds of analytics. Obviously, sometimes when you get a report, you use that report to decide if you should do something or not. Well, that would count as deciding. Similarly, when you have a dashboard and you look at it and what you see makes you do something differently from what you would have done if you'd seen something else, well, that's deciding too. So there's reporting, there's monitoring, there's deciding. And we ask people, what do you do? What's the primary focus of your investment in analytics today? And today, as you can see on the left there, 37% said it was mostly about reporting, 37% said it was about monitoring, and 27% said it was about deciding. Well, okay, that's kind of interesting. But then we asked people to project, people participating in this research, to project forward a little bit. And as you can see, you've got this dramatic shift. Now, in 12 or 24 months, 70% nearly of people are saying their primary focus is going to be deciding, and much smaller percentages on the rest. And for those of you who are like statistically minded, yes, we did check that no one who said reporting before, no one was in the 4% of reporting who wasn't in the 37%, and not, you know, right? So it wasn't like people moved from deciding to reporting. They all moved the way you expect them to. So what we see is this focus on deciding, decision making, becoming more and more front and center for analytics professionals, for BI professionals, data mining, predictive analytics. And so that creates an argument, therefore, that if we're going to do requirements for our business intelligence projects, we should think first and foremost about the decision making we're trying to improve. And so that leads us to this idea of decisions first requirements, this idea of putting decisions first when it comes to analytic requirements. Instead of saying, here's my data, what insight can I derive from that data? And put that insight out there as reports, as dashboards, as data mining results, as a predictive model, and hope that it will improve people's decision making. Instead, turn that on its head and beginning, I like to misquote the late Stephen Covey, beginning with the decision in mind and say, okay, if that's the decision we're trying to get better at, what insight would help us do that? And what data do we need to assemble, clean, integrate, provide, and analyze in order to produce the insight that will help us make a decision? That has some other consequences too. It forces organizations to decide what makes a decision better. For instance, what would a good decision look like? That's a question that turns out to be surprisingly hard to get people to answer sometimes. So this is the approach we're going to talk about. Now, before I get into the details, I want to take a minute to talk about decisions. Now, on one level, obviously, decisions are a very straightforward idea. We make decisions, right? And generally what we do is we look at a set of data, a set of facts, we apply some kind of knowledge to them to say, what do these facts mean? And then we make a choice. Sometimes we choose to do nothing, sometimes we pick from a set of options, we might set a score, we might do any number of things, and then we act in some fashion because of what we've decided. Some people like to think of it as eliminating uncertainty. Before you make the decision, you are uncertain what's going to happen next. Once you've made the decision, now you're not uncertain. Now certainty is restored. And we make these decisions really in 3 ways, or 3 points in time really, as part of a business process. So we have a process that gets to a certain point, and we can't continue that process until we decide something. I'm onboarding you as a client. At some point in that process, I have to decide if you're a valid client. Maybe I have to decide if you are who you say you are. I have several decisions to make, and each time my process has to stop while that decision gets made. The second thing we see is that some event happens. We get a new piece of documentation about a client. We have to decide if that's the last piece of documentation, and we can therefore process the client. We have to make decisions when events arrive at our business boundary. And sometimes, how many of you are like in IT, systems development type folks? Okay. Sometimes, of course, people just tell us they want to make a decision, and we don't really know why. Now, probably there's a process or an event going on outside of our sort of ken, but nevertheless, they are just arbitrarily saying, I feel like deciding whether I need to hire more people next month or not. Help me make that decision. So we make all these different decisions, and they fall in different categories. And some years back, I wrote a book called Smart Enough Systems, and we were joking earlier. Curiously enough, it's been translated into Russian for reasons that were never adequately explained to me or my co-author. As I was just joking with some of the Russian speakers we have, it's a little bit disconcerting to have a book in a language you can't read but you know what it says. You know, I wrote the book, right? So I know what it says, but I can't read it. Anyway. And in this book, we proposed a 3-tier structure for decision making. We said, organizations make strategic decisions. And these typically don't repeat. We make them once. If we make a similar decision next year or a couple of years down the road, it's going to be sufficiently different that we can't really think of it as a repetition. Each strategic decision is unique unto itself. Organizations make a lot of tactical decisions about how to run the business, how to staff, whether policies need to be updated or changed. So these are decisions that do happen more often, weekly, quarterly, monthly, and they do have some repetition. They're still pretty squishy, which is a technical decision modeling term, in the sense that they're a little bit hard to sort of be precise about, but nevertheless, they are repeatable. And then we make operational decisions about a single transaction, a single customer. Should we pay this client? Can we onboard this customer? Is this supplier allowed to supply us with this product? Who should we pick to deliver this product from this location to this location? And those operational decisions, animation's messed up there, and the tactical decisions are the subject of what I'm going to talk about. Because the repeatability of this decision making, the fact that we're going to make a decision more than once, gives us the opportunity, if you like, to think differently about how we're going to do the requirements for it. Obviously, if we make a decision once and only once, we're pretty stuck. We don't really have much choice. We can't know in advance how we're going to make that decision, but we can when we start getting into these repeatable decisions. Now, when it comes to these decisions, there are generally 2 approaches to using technology to solve decision-making problems. And BI plays a role in both, different kinds of BI. The most traditional approach is perhaps what you might call a decision support system. In most decision support systems, we're a little bit flaky about what decision we're supporting. We know more or less what decisions about customers or about the supply chain or to do with HR. And so we provide a very generic environment designed to support knowledge workers and managers who do know what those decisions are and try and help them. Then we have this other term that comes up, decision management systems, where we say, okay, we're going to embed more of that decision making in the system and have it do things for us. If you talk to a call center and they've got a generated script, they're deciding what script to use, they're deciding what offer to make you. They're deciding, if you go to Capital One site and you fill out the form, there's an automated system deciding if you can have credit. And obviously you can blend these two into sort of mix and match kinds of environments where some of the decision making is automated and some of it is left to your devices. Perhaps the system limits your options and you pick between the last 3. Now, BI can be used in all of these. In these cases, we tend to be focused on very visual kinds of BI. Visualization tools, reporting, dashboards, things that help a human see the patterns in the data. These systems, we tend to be more focused on data mining, predictive analytics, more embeddable kinds of mathematical analytics. But most people consider all of these things BI. They're all about, in the end, how do we use these different systems, these different approaches to improve decision making. When I look at these organizations that I work with that are trying to build systems, what I find is that we have a lot of insight in a lot of these companies that has little or no impact. So they build beautiful visualizations, yet people are still out there making decisions based on their gut feel and it smells bad. I'm not going to do that. Visualizations are very pretty, but they don't seem to be changing the behavior of the manager. At the same time, we have mathematicians, data miners, data scientists producing tremendously powerful predictions, powerful analytics that don't seem to be changing the behavior of any business processes or systems that are out there. The typical enterprise application that your call center staff, your frontline workers are using is still as dumb as toast. The analytics do not seem to be making it. There's a missing piece between our ability to do these analytics and our ability to make sure these analytics actually have an impact on our business. And part of that, in our experience, is driven by the game of requirements telephone that is common to almost every business intelligence and data organization that I come with. Someone says, oh, I need data so I can make better decisions. Okay, go to the data people, here's a report, here's a dashboard, here's the data you wanted, whatever it is. Well, that doesn't work. Well, actually, I need this data as well, or this other data, or more data, or different data, more up-to-date data, big data. Well, sure, you can have that too. Well, that still doesn't help. And in the end, they ask you for the classic report, which is just, I don't want any formatting, just put all the data in columns. Yeah, okay. Know what you're going to do. You're going to dump that sucker into Excel, aren't you? And this creates, therefore, a challenge. So we need, we would argue, a different approach to doing BI requirements. We need an approach that will allow us to be absolutely clear what decision-making needs we have. That enables us to engage not just the IT team, but the business team and the analytics team, the BI team, everybody involved, and they all share an understanding of what the business problem is. And that will enable us to deploy the results of these analytics. But it'll be clear which processes, which systems, which organizations have to be deployed. We'll know what a better decision would look like. We'll know what we have to track to prove that we actually made better decisions. All of that will be clear. So that's what I'm going to talk about. I'm going to talk about this idea of modeling decisions and using a modeling notation to describe decisions to do a better job of expressing these requirements. Now, before I do, I want to ask a few questions. How many of you would say you primarily work with, you have to wait till I finish the question, business intelligence, visualization kinds of tools aimed at a human person? How many of you would say you are like data miners, data scientists, predictive analytics types? So how many on the visual side of the analytics spectrum? Okay, how many sort of, mathy geeky type people? Okay, all right. One of the interesting things about this notation is it grew out of the frustration a lot of us had trying to build very sophisticated decisioning systems, things like automated credit assignment, fraud detection systems, where you've got lots of moving parts that have to be combined. And what's been interesting the last 3 or 4 years as we've used the approach is how much more common than that this problem of not understanding decision is. All right. Now I am going to, by the way, I was asked to give a demo too, so I will show you a little bit of the software we use to build a model. You can see a live model, we'll play with it a little bit, assuming that Microsoft's network stays up long enough for me to do that. But I'll show you what the diagrams look like in slides and everything else, because then you can ask the slides and get them from me. So we're going to use this notation. It's a new notation, recently standardized by OMG, which doesn't stand for oh my god, it stands for the Object Management Group. My teenager laughs every time I talk about the OMG, it has to be said. He finds it intensely funny that there's a very, very boring organization out there called Oh My God. Anyway, so the Oh My God specification for the decision model and notation standard is now approved. We've been working on it for years. Anyone worked on a standards committee? Okay, my advice to you is don't. You know that old joke about sausages? Don't ask how the sausage is made, just eat the sausage. Right? Don't ask why the standard has the things it has, just use the standard, okay? Because really you don't want to go. And it has these 3 use cases, and it was designed to work as a single notation that allows you to build all these 3 kinds of models. It lets you model human decision making. And we've done that in a number of places. It allows you to model the requirements for more automated decision making. And because it's the same notation, of course, you can model a decision which you're going to partially automate as well. And in theory, you can, in fact, annotate these models to the point where they're executable. Anyone played with executable BPMN? Okay, if you ever have, it's a painful process. So this is not my favorite scenario. I prefer these 2. This turns out to be hard. And we are, as you can see, one of the original submitters, along with a few companies you may have heard of, like IBM, Oracle, TIBCO, FICO. Real companies. Now, that's the funny story. So, I have a VP of Biz Dev, and she's constantly on me about this, because my tendency always, if I've got a story to tell and something to explain, I'll explain these pieces. And then I'll explain how those pieces build up to these pieces. And then I'll tell you why those pieces go together. And then in the end, you'll find out why I was talking about all this stuff. And she's like, James, sometimes people would like to know where you're going before you start. So the next slide is in just for those people, okay? This is a decision requirements model. This is a decision requirements diagram for a particular decision. I'm going to put it up there, I'm going to describe the scenario, and then we'll talk more about it as I show you how you will. So let's imagine we are a support organization, and some bright new management recruit has come in and said, we want you guys to stop being a cost center and start being a profit center. So we want you to make a cross-sell offer at the end of every call. So the decision we have to make is which marketing offer we're going to tell you about at the end of your support call. That's the decision we're trying to make. As we look at this, we say, well, first thing we need to know is, well, we have to know what data we have to provide to someone so they can make this decision. So those are shown as what's called input data. The information that you need to have available, that needs to be input to your decision making, is shown using the opens. So in this case, you said, if I want to pick an offer for you, I need to know, A, who are you? So which customer am I talking to? And B, what offers are available? But that's not enough. I need to understand how I'm supposed to pick a suitable offer for you. There is some know-how, some knowledge that tells me how to go about this, tells me what I can do, what I can't do, what might be effective or not, and those are shown using this document shape. Now, funny story, we picked these shapes because we thought it'd be really easy to draw on whiteboards, and it turns out that this one is an absolute bugger to draw, so it's an abject failure on that part. Anyway, so having done that, we can see not only can we describe these relationships, we can start to break down our decision making into more and more granular components. And you'll see why that helps and what we do with that as we move through. So this is a decision requirement. It's a classic example of functional decomposition, for those of you who are into that. It's a way at some level of normalizing your decision making and your rules so that you don't have complexity that's hidden in the way you describe things. And it's a way of being clear what data you need, why you need that data, what analytics you need, why you need those analytics, and what other knowledge, policies, regulations might constrain your decision. So now you will know where I'm going. How do we get there? Well, the decision-making approach we use is a relatively simple one. First and foremost, and it has to be said that a certain number of projects do really have a hard time with step one here, which is actually defining what decision they're trying to improve. Having done that, we have to describe it and get agreement on what that decision is. How do we make this? What is the decision we're trying to talk about? And then we ask ourselves, well, what do we need? What do we require to make this decision? Do we require information? Do we require knowledge? And do we require other decisions to be made first? Precursor decisions, sub-decisions. Now, once we've done that, of course, as we go through this step, what we do is we identify new decisions, some of which we may already have described, but many of which will be new. And we can, oops, there's meant to be an iterative loop here. We can then go off, describe those decisions, figure out what their requirements are, and keep iterating through this process. So this first step, how do we find decisions? Not the main focus of my talk today. I spend a lot of time teaching people how to do this when we run workshops and so on. But there are 5 techniques we found that are really effective. The first is to look at your business processes. How many of you work in companies that use business process models? Okay. How many of you have business process models you can wallpaper a room with? If you ever have a business process model that looks more like a rail yard than a process, you almost certainly what you've done is you've mixed decision making into the process. You have lots of gateways and branches. That's describing decision making. But sometimes you get lucky and someone just has a task in the process that says decide this, validate that, calculate this other thing, determine this. Those are decisions. So they're often very easy to find in business processes. Second thing you can do is look at your existing business intelligence reports. So you can look at a report and you can say, well, when you get this report, business user, what do you do? And does what you do vary depending on what you see in the report? Because if it does, you just made a decision based on what that report told you. And perhaps they don't do anything when they get the report or when the dashboard gets refreshed, but they refer to it sometimes. So you can say, okay, well, if you don't do anything, if it doesn't prompt something, what makes you refer to it? When you go look at it, and they say, oh, well, when I'm trying to do X, I'm trying to decide Y, I'm trying to pick between these 2 options, I go look at these reports or these dashboards. Well, again, they're using that content to make a decision. And if you know what that decision is, you'll be able to build better intelligence outcomes. As a side effect, if you ask those 2 sets of questions of a given report and no one can answer either of them, you probably don't need the report, because that means no one's not prompting any action and no one's referring to it when they make a decision. That's probably just what it's discussed. So you can use PI. My favorite is to begin with your metrics, your key performance indicators. Many of you, I suspect, are in organizations that are investing a lot in key performance indicators and metrics and so on. And one of the interesting questions is, well, metrics are designed to motivate behavior. I tell you your metric is customer retention in the hope that you will do things that will retain customers. That means you must be making decisions that can influence a customer's retention or not. Because if you can't do anything about customer retention, it's not very motivating to tell you I'm going to measure you based on customer retention. So if you look at your KPIs, you can often find decisions that impact them. There are various ways just to brainstorm this. Not my favorite way of doing things. The problem with brainstorming is whoever's your audience will only think about the decisions they have to make, and you normally can't get the people who work at the front line of the organization away from their operational jobs long enough to find out what their decisions are. And there are often opportunities for what we call micro decisions. Micro decision is a decision that was previously made about a large group of people that now is made about a single person or a single transaction. Instead of saying, here's a generic letter, I'm going to send it to all of you because you came to this meeting, I'm going to use what I know about you, including the company email address I have for you perhaps, how many times you've been before, what your job title is, and I'm going to send each of you a slightly different letter asking you to do whatever I want you to do next. That's a micro decision. I'm making a decision about each letter instead of deciding to send all of you the same letter. This works in checklists. Instead of having a checklist, I generate a checklist for a particular transaction and so on. So micro decision. But once you've found these decisions, whatever the decision is that you have to improve, now we have to model. So the first step in this is to describe the decision accurately. As I say, this is surprisingly difficult in some organizations. We've spent a long time arguing over some decisions in some projects. And one of the most effective tools we find for doing it is to write a question. And with that question, a set of allowed answers. Now, allowed answers, that's a slightly odd phrase. But you think about it, these are decisions we're going to make more than once. So we already know we're going to make the decision again. If I know I'm going to make the decision again, I should have some sense of what the possible answers are. Because if you're making a decision every day, every week, every second, every time you interact with a customer, there probably aren't, in fact, an infinite number of possible answers. In fact, there's probably like 2 or 3 most of the time, except reject, refer. Yes, no, maybe. So here's a question for this particular decision. Which marketing offer should be presented to this customer during this interaction? In fact, I would probably be more specific than that and say, which of our currently valid marketing offers should be presented to this customer during this interaction? The more context, the more constraints you can put on the question in general, the better. And then we say, well, what's the possible answers? That might be yes, no, true, false. It might be one of a set of values, accept, reject, refer. If you work in insurance, that's a pretty common set you'll see a lot. It might be a number, like a FICO score. It might also be something that's in your database. In this case, that's what we have. Any of the currently available marketing offers that are recorded in our database. But now we have defined, we've bounded our problem by describing what the allowed answer is. Now these decisions can be put in context. Particularly when you get to more advanced analytics, it is surprisingly easy to build a very powerful analytic and then not have it get deployed or used. And 2 things cause that to be a problem. The first is that the processes, the systems, the technical environment where that was meant to be deployed doesn't match the way the analytics people have built the model. We have one extreme example where we were working with an insurance company that had an old COBOL mainframe system, and so the task for the analytics team was set to saying, you can use any analytic technique you like, but the result has to be an integer. Because the only field we have left in the COBOL copybook is an integer field. And so in order to plug it into the system, it's got to be an integer. So none of this, don't get fancy. Give us an integer. And it would have been very easy for that team not to have known that in advance, to have built a model that was highly predictive and totally unusable because it wasn't an integer. So we want to make sure we understand that business process context and system context. We also want to understand which organizations, which roles care about this decision. Who gets to say how we make this decision? Who gets to approve it? Who has to make it every day? And what do they care about? How are they measured? Are there other people in the organization who have an opinion about how we should make this decision? And the answer to that question, by the way, is yes. For every decision you have, there's always someone who thinks they have an opinion about how you should make the decision, it turns out. And then we like to have some sense of what business performance indicators, business objectives, we might be able to miss or hit depending on how well we make the decision. Primarily because we'd like to be able to tell good decisions from bad decisions, but often because we would like to know what the trade-offs are. Now, anyone working in a bank? Okay, at least briefly, right?
No.
That's temporarily.
Temporarily,
right. But banks worry about credit card fraud, right? They worry about the amount of fraud from credit card. But you could, in fact, if you told me you got to make decisions about accepting credit cards, and the metric I care about is the amount of fraud, I can guarantee you I can reduce that fraud level to 0 tomorrow. Just don't accept any credit cards. Reject it. No fraud. Right? Well, actually, that's because there's more than one metric for that decision. There's, yes, we do care how much fraud there is, but we also care about our total credit card volume, and we also care about our false negative rating, because we don't want to turn you down when we shouldn't have done. And if you're going to make a good decision, you have got to trade off all those metrics. Well, that requires you to know what all those metrics are. Now, for accepting credit cards, that's a well-known problem, but many decisions, it's a lot less obvious what the performance indicators or objectives should be. So now we have our decision and we know what its context is. We're going to ask the most obvious question. What information do we have to provide to someone who's going to make this decision, or to a system that wants to make it? And generally this is going to be transaction data, so data about the transaction we're trying to decide, the thing we're trying to decide about. Sort of related case data, if you like, things that are connected to that in some fashion. Or it's going to be sort of reference data that we have to look up. And in DMN, we show these using ovals. How many folks work on enterprise information models or data models, logical data models? Okay, right. So these are going to be business entities, frankly. I mean, they're going to be the logical pieces of business data in your system. Now, something like customer, I was looking at a health plan recently, and like member, they have thousands of fields per member. So you would break up really big entities into several. But these are meant to be logical clumps of data. They're not meant to be individual data fields. And we showed them using this solid arrow, which is called an information requirements link. So what this diagram is telling you is that in order to make this decision, we require these two kinds of information. Now, for reasons that I won't bore you with, there's no distinction between always and sometimes. So if you ever need the data to make the decision, it gets the link. Okay, so there is no distinction between, well, I always need to know that and I sometimes need to know this. It's all just requirements. Turns out to be easier to build the models, that's why we do it. Now, so far I haven't really done very much that most people wouldn't have done fairly automatically without a modeling notation. So, you know, at this point, often people are like, yeah. So now we're going to move on a little bit. We're going to say, well, it turns out that if I want to describe decision making to you, I need to think about how you make this decision. How will you know how to make this? If I needed to teach you how to make this decision, what would you have to go reference? And it turns out that often there's a wide variety of these things. Often you need to go talk to people. Best practices, tribal knowledge, experience is the big driver. He actually had literally on one diagram the other day, tribal knowledge show up because there were some thresholds in the system that needed to be in the decision making. And so where do those thresholds come from? We got no idea. Everyone knows those are the thresholds, but none of us know why. They've all been around so long we've all forgotten, but they seem to work. Okay, well then that's what we got, they're tribal knowledge. But you also get regulations that you have to follow. You get policies that you're supposed to follow that constrain how you're supposed to make this decision. If you're really unlucky, there's a legacy system that embodies part of the decision making, which now no one can remember why it decides what it decides, but it just does. And then of course, we like to infuse analytics, business intelligence, into this decision making. We would like to be able to provide knowledge about the patterns in your data so that you could make a more accurate, a more precise, a more profitable decision. So all of these are different kinds of knowledge, and we need a way to show what knowledge goes into which decision. And so for that, we use this thing called a knowledge source, which explains why it isn't displaying. It's a good question. Obviously, you need to just whack it. So a knowledge source is shown. That was easy for me to say. A knowledge source is shown using this document shape. Oh, I turned my clicker off, that's why I didn't work. I'm aligning my laptop, but I just turned the clicker off. So these are the document shapes. And so we're going to document things like, well, what tells me what I must do, what I should do, what I can do, what I will do, what I should probably do, and crucially from an analytics perspective, what would help me make it better. We often talk about the if only question. But if only I knew which customers were going to cancel their service next quarter, I could do a better job of picking a suitable marketing offer. If only I knew which of these people was lying to me about who they were, I would have less fraud. If only I knew which of you was putting fake data on your tax return, I would be able to reclaim more of my tax dollars, and so on and so on. They show up as knowledge sources. They have this little document shape. They can be any of these things, policies, regulations, or business intelligence artifacts of one kind or another. And they are linked to the decisions they have an influence over using this dashed arrow with a little round end. The knowledge source at the blunt end influences the decision at the not very pointy end. Again, if you want to know why that's called an authority requirement, trust me, you don't want to know why it's called an authority. It just is, okay? So now we can say this decision, select marketing offer, if we want to make that decision, we need access to information about the customer we're trying to make the offer to and the available offers. And to pick between those available offers, we know we're going to apply some marketing know-how as well as some product eligibility guidelines, because we don't want to offer you a product that we'll have to turn you down for later. I realize that that doesn't seem to be in the decision-making of many organizations, but it probably should be. So then we get into this last piece, right? We start to describe the decisions we have to make before we can make the decision we're trying to make. So in this case, when we're making this story up, remember, this is a made-up example. So just in case you think I don't have little voices in my head that I talk to about this. This is just a made-up example. Let's imagine we could talk to some of these little voices in my head, and they say, well, first of all, the decision actually is, what marketing offer should we make to this customer, if any, at the end of the support call? Well, why wouldn't we make them an offer? Well, if they've just called for the 10th time to complain about the same bug, we probably don't want to make them a cross-sell offer, because they're just not going to be in the mood, it's a waste of time. So we want to make sure that now is a good moment. We want to check the timing. Is there something about the circumstance that tells us the right answer to this question is no offer at all? And we have a lot of products in our product database, so we would like to limit that set of products to some reasonable candidate set so that you can pick between them, obviously. So we want to determine the offer product or products that make the most sense. And then frankly, some of our offers are really expensive. You know, buy one, get one free, and some of them are dirt cheap. Get a free pencil. So we want to know how valuable an offer can we make you. Because if we should make you a really expensive offer, great. But if we're meant to make you a really cheap offer, we don't want to mess up and make you really expensive. So what we're asserting in this diagram is that in order to make this decision, not only do we need this information and need to apply this knowledge, we also need to make those three decisions for the same transaction, for the same context. And only if we've made those three decisions can we go ahead and make the ultimate decision. Now this is an iterative process. I've identified these decisions. I can ask the same questions about those decisions. And I can ultimately iterate. There's my iteration flag. Just forgot which slide it was on. It's hiding all the time. Because now I've got new decisions, I can ask that same set of questions. I can write questions and allow answers for those decisions. I can describe them. I can start capturing their requirements. And ultimately I end up something that looks like this, which is probably familiar because it was a slide I started with. So now I've got this check offer timing decision. Well, how do I decide whether now is a good moment or not to make an offer? Which is probably a simple yes-no question. Well, I'm going to consult your service history, which tells me what calls you made before this one. And the service expertise is really all I've got. The service department is going to have to tell me what kinds of patterns are a bad sign. All right, how do I decide what products I might offer you? Well, that's actually where I need to decide which ones you're eligible for. And I'd like to make sure I met some unmet need that you have. Classic salesy kind of stuff. I'd like to identify an unmet need of yours and then pick products that seem like they might meet that need. And those two things between them will allow me to pick a set of offers, a set of products that might be candidates. And you notice that the eligibility guideline is now down here, because that's really where it's needed. It wasn't about how do I pick offers, it was about how do I make sure that the offers that get fed into that decision are eligible. And then offer value. Some marketing guys decided we're going to do the classic value loyalty grid. High value, high loyalty, high value, low loyalty, low value, blah, blah, blah. You know, the 4-quadrant thing. And we'll do a high, medium, low, and nothing as the offer values out of that. So I've got to decide how valuable a customer you are, and I've got to decide how loyal a customer you are. Well, to decide how valuable a customer you are, I'm going to look at your order history and the product profitability guidelines I have and calculate how valuable a customer you are. And if I want to see how loyal you are, well, I could do an account assessment, but really what I want is I want the analytics guy to tell me how likely you are to churn. And then if I ask the if only question, I might say, well, actually, it's not enough to have the marketing know-how. I'd like some kind of analytic that might tell me how likely you are to accept some of these offers, because that would be much more successful. So now I still have my top level decision. I still have my input data and my knowledge sources that describe that. But now I've started to expand my model. I've got additional precision in my decision making. I've got a better sense of how the decision gets made. I've got new requirements. I didn't originally identify that I needed service data or service expertise as part of this decision making, yet I clearly do. I've identified much more specificity about where I need some of these things. And I've got gaps. You notice that I have no input data or no knowledge about how to make this decision. I'm just asserting that it needs to be made. Well, that might be okay, I might say, and frankly, the people making this decision can do that, so I don't need to know how they do it. But it might also be a sign that I've got other questions I should go ask. Well, how do we do that? What does that look like? What information would we have to present to you so that you could do this for yourself? And notice there's nothing in this model that says, I'm going to automate this, write a bunch of business rules for it. Nothing in this model that says, I'm going to build a predictive analytic to do this. Nothing in this model that says, I'm going to build a visualization or a dashboard or anything else. It's just describing the business decision making that I would like to improve. So, anyone else here an education reform nut? Reads all the stuff about schools and education and stuff? Well, I do. One of the key bits of data that they discovered the last, education's a bit slow at responding, so the last quarter century, is that actually the worst way to learn anything is to sit still in a room at a desk and have someone at the front stand up and talk to you.
Amen.
And I realize the humor inherent in me telling you that. However, it is unfortunately often the only way I get to do this. So the best I can do is make a joke about it, say I appreciate your patience, and if you need to stand up, move your toes, do the airline stretches under the table, doesn't bother me, don't worry about it. I'll happily do something else while you do that. But I was told that a demo would be appreciated. So what I thought I would do is show you a little bit of software we have that we use to model these. And I'll show you, it's a slightly faked example, but based on a real next best action project we did at a bank. All right, so I'm just going to go ahead and see if my internet connection is still working here. I'm just going to log in. So the tools are classic sort of cloud-based multi-tenant thing. Let's see if this actually is going to work on the internet connection. This is the big question. Will it work? Yes. And so I've been working in here. You can see that I'm not the only person working in here. We would be able to show more activity. Maybe we've got other people who've been in the data. So obviously, I'm the one who's been in the most recently. And I'm going to start off by showing you, I'm only going to show you really some of the core functionality because I don't have all that much time. So let's go look at this diagram. So this is a next best action model. So at the top here, you can see I've got this key decision in the middle, which is what is the rank ordered list of actions available to me for this customer. And that decision is used by a decision in the branch to say what should the branch person say to you. It's used by a decision in the call center to say what script should be generated. Lots of decisions use that decision. And then I can describe, well, how do I decide what the rank ordered list of actions is? Well, I've got to decide which actions are actually available. Because not every action is, not every marketing action is, not every product action is. You have to own certain products to be eligible for certain actions. Those are the add-on actions. Marketing has to be running certain kinds of campaigns. Customer service has to be up for certain kinds of actions. Secondly, I need to know how valuable, what's the incremental net present value of each action. Well, in that case, I might say, well, that's going to be based on how valuable the action is to me as a bank and how likely you are to take it if I suggest it. Clearly there might be I could have an action which was, please send us $1,000 that we'll lose and just keep the money without giving you anything in return. That would be a very profitable action, but the likelihood that you would do it would probably be close to zero. So the net present value of that action would be zero. Now, if you look at this and you work in a bank, the obvious missing point here is, you know what? There's nothing in here about risk. Nothing in here about credit risk. And many of the actions involve products involving credit risk. So I should probably go see if I've got anything in here about risk. I'm just going to go ahead and search. It's a repository-based tool, so everything's in the repository somewhere. And let me have a look here. So here I've got this decision I've already defined in the database, already prepared like a cooking show, the risk of action. So I'm going to pull that onto the model here and add that decision. So now I've got another decision in here, which is, well, how risky is this action from a credit risk perspective? And I'm going to build a link to say, well, in order to decide what the rank ordering is, I need to know that as well. And so now I've added that. So now I've said, okay, that action requires these 3 subordinate actions. So I can go through this process, reusing decisions, adding them into my model, and build up a sense of what my decision making is. Now behind these objects, if I was to go into one of them like this one, there's a whole set of information. You can see mostly it's faked in this one. You can see here I've got a set of the requirements. You can build lots of those diagrams, and this pulls together everything that you know on all the different diagrams, so you can see it. You can see it's in multiple diagrams here. You can see I've got my question, because I define a question instead of allowed answers for this particular decision. If I've got it implemented, I might have links to implementation. I can capture various properties about it, and I can put it in context. You can see here I'm starting to say, well, which processes need me to do this? Well, I'm only going to generate the script as part of the onboard a new customer process, and it's got to run in the CRM application. And I'm going to tell I've made a good one because I get positive outcomes in terms of multi-product customers and product profitability. So I'm starting to track how I will tell a good decision from a bad one. And then I can start to track organizations. I can start to say, oh look, the retail delivery organization in the bank owned this decision. It's made by people who work in customer service, and it impacts the marketing department because they care which offers we make. And I can start to capture all that kind of information. Now, in this particular example, we had a real example of a classic organizational problem. Their model was bigger than this, but it had more pieces in it. Every single decision in that model was owned by the retail delivery organization or by some part of it, with the exception of that one. The credit risk decision was owned by the risk group. And it turned out that the risk group didn't report to the retail delivery organization. It didn't even report to the retail bank. It reported to the bank group. That meant that if the people who owned most of this diagram disagreed with the people who owned that bit of the diagram, the only person they all worked for was Lord So-and-so, who ran the Lord Bank Group. We didn't think appealing to Lord So-and-so was a good sort of issue resolution strategy. So by modeling this out and realizing that their whole decision-making strategy was utterly dependent on a decision over which they had no control, we were able to sort of proactively set up a process for discussing how the credit risk people were going to change their decision and whether they were going to tell us that they had changed the decision so we didn't get caught out. So a lot of that kind of organizational dysfunction can be identified much earlier. We also found another example where the people in the call center were not motivated by all of the objectives that the decision was. You notice that we had multi-product customers and product profitability as objectives. The people in the call center were incented to sell you a second or third product. They were not, however, incented based on how profitable you were. What this meant was the system was going to make decisions based on whether you were a profitable customer or not. And if you were not a profitable customer, it was going to make crappy offers because you're not a profitable customer. And the call center people were going to hate it. Because they'd be like, here's James, I'm trying to sell him a second product and you're making this ridiculously bad offer. Well, he's not a very profitable customer. Do I look like I care? I don't care. I just want to, I want to get the guy to buy another product. And so, again, building the model, establishing the framework allowed us to identify some of these mismatches. So we didn't end up building analytics, building visualizations or data mining models that were not in fact going to be consumable by the people who build them. Now, one of the, let me go open this decision up for a second here because I want to navigate something and I can't remember where it is. There we go. So in this particular case, I've got this knowledge source. It's an analytic knowledge source instead of product risk models, and you can see here I've got this knowledge source. It's an analytic knowledge source, a BI artifact essentially, that's being used by this decision. But I've also started to identify information and other decisions that are essentially input to this. So I can start to model what data do I have to look at in order to build this kind of analytic. So I can start to build a completely traceable model. It lets me say, here's an objective. Here are the decisions that influence that objective. Here's how we make those decisions. Here are the analytics we think will help us make better decisions. And here's the data we think will help us build those analytics. So we stop saying, hey, we should put all the data together, clean it all up, integrate it all, and hopefully that will improve decision making, and we can follow the training logic to its conclusion. Now there's a lot more in here, but frankly I'm not going to spend all that much more time in it because I want to wrap up so we have time for questions. I did want to show you one other thing. One of the things that we find helpful is that it's good to put these things into more consumable formats. So this is, we have an API for all this data. So this is just a little HTML experiment just to sort of read some of this data. And you can see here we built this object called it's a description of an analytic project. I've described it. I've linked it to the various objectives that we care about. That's the analytic that I'm trying to build. When I generated this, it wasn't connected to that model. And hopefully, if I don't lose my connection again, when I regenerate it, we'll see how that analytic fits in the rest of the model. So you can see here, this is the analytic that affects this decision, which is used by this decision, which is used by those decisions. So now I'm saying I'm going to build this effort to improve that analytic, and that's why. That's the chain of logic that I have to follow. Those will be the decisions I would expect to get better because I had improved this analytic. So I can start to capture that kind of information. So I can turn it on its head. I can say, well, if I've got an objective like multi-product customers, and we're not doing well enough on this objective, so what can I do about that? Well, here's the set of decisions that I could change. How many of you heard the old Einstein expression, right? If we do the same thing, the same way, and expect a different result, we're insane. Now, how many of you have been in organizations where someone said, this objective is not, we're not hitting this objective, or this metric is too low, go out and improve it. And you'd be like, well, what are we going to do differently that will actually cause us to get a different outcome? Well, no one knows, right? So this starts to allow you to say, well, here's a decision, how do I make it better? I'm going to go ahead and bring one up. So there's a call center cross-sell script decision, for instance. We say, well, maybe we can improve that one. It's not the world's fastest internet connection, at least not on my end. And here's all the information we had before. Question, allowed answer, what data do we need, what sub-decisions do we have, how do we know how to do this, what are the authorities, how do we tell good ones from bad ones, what's the application context, and you can see the whole set of things in here, and you can see the question hierarchy that's generated out of that decision hierarchy. These are the questions we have to answer in order to answer this question. So now our requirements for our business intelligence artifacts, whether those are reports or dashboards to help a person make a decision or an analytic designed to make a system make a decision, have a clear and unambiguous context. We know what a good decision looks like, we're all set. All right. I have a few more slides to wrap up, and then I'll take your questions. So, the whole idea of all of this is to generate these decision-centric analytic requirements, where we can define the analytic we're trying to do, the project we're trying to do, we can identify the decision, the question, allowed answers that we're trying to influence. We know why we're trying to influence it, how we would tell good ones from bad ones. We know what processes, what events, what systems have to be changed in order to make this decision work differently. We know which organizations have to be involved and what their relationships are, and we can see exactly how this decision is made because we can decompose it into its pieces. And we've done this in a lot of projects. We used it for business rules projects to scope out business rules and structure those business rules. We used it for predictive analytic projects to identify the use case. We've done it on some dashboard projects. And what we find is that you can take these decision models, use them and combine them with the classic kinds of deliverables like information architecture, user interface designs, knowledge architecture, and use those to pull together a more effective implementation. So the dashboard sort of was a great one. We had a project we were doing with an IT department, and they were using data from one of these sort of quality management systems. And they said, we want a dashboard. And we said, well, okay, humor us for a second. Why do you want a dashboard? You've got to have a dashboard. You know, any Douglas Adams fans? You've got to have dashboards.
Yeah.
Got to build white places. And we said, yeah, okay, true, but what will you look at the dashboard for? And so after a little bit of prompting and some back and forth, we got them to admit that there were a set of decisions they needed to make. Do I need to delay this release? Do I need to move resources from one release to one product to another product in order to get them out on time? Can I justify hiring some additional contract resources? And there were like 8 decisions that they had to make using this dashboard. And so instead of designing the dashboard in a data-centric way, we built this dashboard with a tab for each of these decisions. And each of those decisions, the layout of that tab was driven by the decision-making they described to us. They said, well, in order to decide that, I decide this, I decide this, I decide this, I look at this data, and then that helps me do that. Okay, great. So that becomes the wireframe for the dashboard. So now the dashboard conforms to the model. But there are other use cases too, because what you're doing here is you're explicitly linking the action you want to take, in this case, what marketing offer should we get, to a particular analytic. So when you go and say, hey, look, I want to build a customer churn likelihood model because it's going to improve the way we make marketing offers, and someone goes, how is it going to improve that? Why is it going to improve that? You can follow that trace through the model. You can explain exactly how it is and how much you might decide to have. Crucially, this also uses, as you can tell, a very non-technical notation. This is not a complicated diagram to draw. Most data science organizations and analytical organizations we work with, and I hear about through the Institute for Analytics, are struggling right now with their sort of operational model. How do we scale this? If we can only build enough models, if we only build the models we can hire data scientists for, that's going to be really constraining, number one. Secondly, we've got to make sure we're solving the right problem. Thirdly, we need lots of people out there looking for problems, because I don't have that many data scientists and they can't find all the problems. And then I need a way to prioritize projects. Because if in order to describe a project I have to put a data scientist on it, then I can't really prioritize which projects I should put my data scientists on. Because I don't know anything about the project until I put a data scientist on it, and it's the data scientist I don't have to put on the projects in the first place. So it's like a sort of circular argument. And so we have a very large manufacturing client, headquartered in the valley here, and they have basically said, if you want us to build you an analytic, then you have to build a decision model for the decision or decisions you think you're going to influence in the analytic. Show us where you think the analytics is going to help, and then we'll start having a conversation. Because frankly, you can do this. This is your business. So if you can't articulate what the decision is you want to get better at, and what that would look like, and how you make the decision, what other factors constrain that decision making, then really there isn't much point in us trying to build an analytic. Now they do some researchy kind of stuff too, where it's off, does the data tell us anything we didn't really know before? But mostly, their analytic organization, like most, is focused on how do we run today's business more effectively. Actually, the guy who spoke on that recently, he had a great phrase. He said, one of the things he found was really important. We had 2 very funny things he said. The first was, he said, his experience has been, if you're in a large organization and you find a cost saving using Excel or a two-dimensional model, two-dimensional table, it's a false cost saving. Almost certainly that cost will simply get moved to somebody else, because if it was that easy to save the money, someone would already have saved it. So if you're not using a relatively sophisticated analytic to find the saving, it probably doesn't exist. The second thing he said is that you want to eliminate the white space between analytics success and business success. You want to make sure it is really difficult for the analytics team, the BI team, data mining team to succeed and build a good model that doesn't actually improve the business. You want to narrow that gap. And these models, they feel, really help them do that. Now you saw this already, this idea that we can take a KPI and we can say, well, how do we improve this or we find the decisions that influence it. We can navigate through those decisions looking for opportunities to improve them, and then we can say, okay, we're going to improve that last step in this puzzle. That's what if we improve that, it will have the desired impact. And then lastly, this is the same notation but used to model these are some decisions that rely on this analytic that's built from this data. Once we know that, we can go, well, look, those three kinds of data, they're already in the data warehouse, but that one's not. So now we have a justification for getting that under control, putting it into some kind of store where we can get access to it, investing in the tools that will let us analyze it, because we can show why we would do it. We're not just asking this because it'd be fun to have a Hadoop cluster, play with some new technologies. We're saying, well, look, you want us to improve these decisions. That's what we said you wanted to do. That requires us to be able to predict this, and our data suggests that this will be used. And I did 3 minutes after 8. That's about right. All right. Questions? I have one wrap-up slide, but I'll take questions. Yes.
So I'm sure you guys have this piece, but do you guys have like a feedback mechanism, like say, it's churning out a lot of decisions. Say, is there some point where I say, okay, you know what, like say X% of my decisions were not right.
Right.
Let me just trace back to which matrix was causing this bad and let me correct this.
Yeah. So what we have found with these models is that they do allow you to do exactly that, because they allow you to break down the decision making a little bit more and generally capture slightly more granular data. Because the problem is, if you only know about the top level decision, even if you record what decision you made, it's very hard to go back and look at that and go, okay, well, 25% were crappy, 75% were good, but we have no idea why we made these decisions. If you break it down, you can start to capture information that might tell you how particular pieces were made. You might automate pieces of it so you know what the automated recommendation was. You start to get a much more granular audit trail. Now, you still need the process. We have a sort of decision management methodology that goes with this, and we have decision discovery and modeling, building these decision-making components. And then there's a decision analysis and continuous improvement piece. And I'm often asked, well, can that wait till phase 2? And I'm like, no, it's got to be in phase 1, because there is never a phase 2. So, and the reason for this is that once you start building essentially decision-making into a system, everyone in your organization will forget how to do it. Today, you have 1,000 people who know how to do this, because they're all doing it by hand. You start building good analytics that help them do it mechanically. You write rules that start automating it. Guess what? Now, no one knows how to do it, right? So if you don't immediately put in place some kind of feedback loop, then you're just going to go straight off the cliff, because it's like, sooner or later, someone will come by and say, why are we doing it this way? And people will go, I have no idea. It's just what the system does. Oh shit. The regulators arrive tomorrow and we can't explain why we do what we do. So yes, the feedback loop's really important. The models help you structure an audit trail. They don't create one for you, but they tell you what it needs to contain. Which book do you want?
I was pointing at like more, setting up, correcting your matrix basically, that what's more important and what's not.
Yeah.
Oh.
Which one?
You tell me which is. You've written those books.
Do you do business process stuff at all?
A little bit, yes.
Well, then it's a tough call. This one's only about modeling. This one's less about modeling, but more about systems and technology.
I'll take this one.
All right.
Thank you.
All right, another question in the back. Yes?
So this seems to fly in the face of the wave of self-service. In the same way that companies used to spend a lot of time modeling their data, but now we just release power pivot.
Yeah.
Or spend all the time building a balanced scorecard and then going, well, it didn't really pay for itself.
Yeah. So self-service is a really interesting question. I did some, that research I spoke about right at the beginning. We did this analytics capability landscape, and what we argued was, it really depends on the kind of decision you're talking about. If you have a decision you make thousands and thousands of times a week, even if you want the people who have to make that decision to self-serve, so they can gather the data they want to make a decision with, you probably don't want them all to make it up themselves, because you're making it 1,000 times a week. 10,000 times a week. The bank we did that next best action for makes that decision 140 million times a month, right? Not going to self-serve for 140 million times, it's just not. And so what the models allow you to do is say, here's a best practice framework. Here's what works. Here's a structure. Sure, within which you can decide how far down that model you need to go. You might look at that and go, well, I know the answer to those 3 questions. I'm not sure about this one. I'm just going to look at that piece. It's not requiring you to stop being an investigator of your own data. It's just putting a framework. Now, there's a balancing act always with these things. But yes, it is a little bit, there's a little bit of tension between the two. What I would say though is we have found that even building very, very simple, very high level models dramatically improves everybody's ability to understand what they need to be looking for and what they need in a self-service environment, what access they need. Do they need a mobile environment? Do they need it to be up to date? Does yesterday's data work? Do they need today's data? And you can't answer any of those questions. What you end up doing is saying, well, I don't know what decisions you might make, so I have to provide everybody with a completely self-serve, up-to-the-minute, real-time environment that runs on their tablet, because then I'm covered. Yeah, that's one way to do it.
So to be devil's advocate here, so if it's a repeatable decision like this, which infers it's an automated decision, why go
potentially
through,
automated, yes.
automatable? Why go through the analysis decomposition stage rather than looking at history and building a data mine model?
Oh, sure. Well, how do you think we fill out the logic behind many of the boxes on there? It's done with data mining, right? That's what it's for. The problem is twofold. What we have found is, first of all, if you try and mine data or you try and mine code for rules and logic in a completely free-form way, you end up with what we jokingly call a big bucket of rules. Yeah, they're all true, but it's not obvious what they're for and how they fit together and how you might change them and when they might need to change and who might need to improve them or any of that kind of stuff. Secondly, sometimes your data mining or your history or your experience tells you one thing and the current policies and regulations tell you something different. And so you have to, if you were to be a tobacco company, you were to go mine your historical data, you would say that 15-year-old boys are a great target audience. However, your little decisioning engine wouldn't target 15-year-old boys because there would be a node in there which would say, are we allowed to target this person? And it would say no, because there's a regulation. So the modeling notation, the more formal version, people who use it formally to build quite detailed models tend to be in regulated industries, and they tend to be focused on decisions that get made a lot. As you dial back the level of regulation and you dial back the frequency of the decision, the models tend to get less detailed and be more high level and more flexible. So we did some work with an insurance company just recently. They're building a new analytic. And the reason they're going to build the model is really so they can show the underwriters where that analytic is meant to fit. So it doesn't get used in ways it wasn't intended for, and so they can put it in context. But they're not necessarily expecting all those underwriters to follow the same decision-making model, but they want to have it there as to frame the analytic at least and describe it. So yes, as with all modeling notations, there's a balance point, right? So it's like data modeling, right? Yes, I could in theory just put all the data in and not think about the data model at all, and sometimes that works. Or I can certainly spend way too long trying to formalize the perfect enterprise information model before I let you do anything. That doesn't work either, but the balance is somewhere in the middle. The best example I got was years ago I worked with some guys who invented the first sort of like RAD methodology at wherever they were, DuPont or something. And he had a great analysis. He said, think about buying a house. At one extreme you could say, I'm going to sit down, I'm going to think of absolutely everything I want in a house, and I'm not going to look at a house unless it meets every single one of those requirements. It's very long-winded, probably not very effective, but you don't look at very many houses, so it's cheap, right? At the other end of this process, there's someone who says, I'm not going to write down any of my requirements, I'm just going to go look at houses and then figure out what I like based on what I see in houses. Well, they get to look at a lot of houses. The first example is writing requirements and building models. The second example is pure prototyping, rapid application, about do whatever I want. And he argued that if you take those extremes, there's clearly a balance point. I write down some of my requirements. I go look at some houses that meet those requirements, and then I change my requirements based on what I find. And we find the same kind of thing with the model. Often you put a high-level model, you'll look at it, and they'll go, well, everyone makes those 3 bits of the decision perfectly well, but this bit, that's a pain in the butt. It's not consistent, it's very difficult, so you model that piece in more detail. So you often see these wildly unbalanced models. high level here, and there's one leg that's like, you know, really detailed because that's where the regulations apply or whatever it is. Thank you for causing trouble. Yeah. Yes.
Just follow up on that question. You mentioned about the balance between the very detailed planning versus gut feeling. I wonder if based on your experience, did you see the size of the company matters? And how does that dynamic play into this balance?
Yeah, so size of company, so this size of company matter. Yes, at some level size of company does. Bigger companies tend to have more analysts, they're more worried about scale, they're more worried about recording why they do what they do than small companies are. But really it's the number of decisions you have to make of a particular kind. So if you're a very large company, you probably have a lot of decisions that get made over and over and over again. If you're a small company, you probably have fewer decisions that get made over and over again. But if you're even if you're quite a small company, you don't have to have very many customers before you start thinking about, well, what's the right discount on an order? Well, that's the decision you make every time someone places an order or asks you for a quote. Well, you probably do that relatively often. And so the value of the repeatability tends to go up. So what I notice is in small companies, the number of decisions that are worth modeling is often quite small. In a bigger company, the number of potential use cases tends to go up because more of their decisions meet that threshold. Extreme cases are like software companies, which often only have one decision because the whole software is designed around making a decision. And so they don't have very many decisions that they have. Big ones do, but lots of software products are very focused. So that would be my. So yes, bigger companies do tend to do it more often. They tend to care more about models. They care more about documenting why they do things, and they have more decisions. Yeah, you follow?
But then would that mean that as long as, like, say, for example, the quotes, because I quoted discounts, even though the small companies has fewer of those questions, but because of that question is quite important to the company, and hence such models would still be important.
Absolutely.
To
Yes.
smaller ones.
Yes, for sure, because they tend to be the core decisions, right? And even in a very large company, you'll find, and we're doing some work with a big investment bank, and things like client onboarding. Which clients can we have and who can we have as a client is a really important decision, because if you accidentally allow a Russian oligarch to do trading, then you're in big trouble, right? But then we had another decision that they were talking about they make once a month. And we're like, well, why are you so focused on this model? Because it's once a month. How hard is this? They said, well, because if we ever get the decision wrong, we can't do business in this country ever again. Okay, sure. We should probably have a model for that then, because the consequences of getting it wrong were catastrophic. So they wanted to be really clear how they made the decision. They wanted to show that model to a regulator and say, here's how we're going to decide, is that what you meant? So even though they didn't take it very often, the transparency was hugely valuable. Yeah?
So, I've been in a company doing BI for 5 years now. The company started at 0. Everything was really, so a lot of people had consultants in, all this expertise. So I witnessed between paralysis by analysis and nothing gets done to our user needs something and it has to be, we're a year behind already and you know the deadline's here. So my question to you is, like Kimball's methodology talks about breaking things into chunks that you can deliver in 30 or 90 days. What is your experience, or do you have any insight as to when you do modeling, what is your time frame that you work with?
Yeah, so we've done both. I mean, we certainly have some folks who are very focused on that kind of rapid turnaround time. And generally, in those circumstances, we've built tremendously detailed models for these things in days, right? I mean, in a week, if you have the right SME access to normal constraints, right? But we've had other very long-winded regulatory kind of things that go on for months and months and months to get the specifications. Like we did one project for how do we decide that the paperwork for this annuity is in good order. Now, annuities are horribly complicated. Things like beneficiaries. Well, what paperwork do you need for a beneficiary? Well, if you're married to the beneficiary, or if you're married to someone but they're not the beneficiary, depending on which state they live in and which state you live in, it's different paperwork. So there's like 3,000 rules for this thing. So that took like 9 months to get that model right, because it's a horribly complicated model. So a huge variation. But to your question, yes, we have folks who build one piece of the model, go ahead and say, okay, we agree how we're going to do that piece of the model, we'll go build out some analytic or some rules to support that piece. Now we're going to look at the next piece, and they'll do that as a very iterative thing. So they start off with only the top layer of the model. What are the 5 key decisions we have to make? Okay, first phase is to do that one. Second phase is to do that one. Okay, this one's actually pretty hard, so we'll do one more layer, and then we'll do one piece and then the other piece, so that it gets broken up into pieces. And because you always have the context of the decision, you can build the pieces. Yeah, because you're not quite constrained. Now we have other people, of course, who build the whole damn model, and then start a 9-month death march to build the whole thing. The nice thing about the notation is it doesn't really care. Methodologically, I prefer the slightly more regular iterative development, and I find that the model, the high-level model, makes it easier to fit the pieces in as you build them. Because you start off saying, you make this whole decision. Well, now you make the whole decision, but we have now for that bit. Well, now you make the whole decision, but we have now for that bit, and we'll tell you what the answer to that bit is. And gradually, the level of support for your decision making goes up. We actually have one insurance company that's going to read the model through the API as part of their their help interface, because that means if they decide to change the model, they won't have to go rewrite the guidance for the users.
Robocalls were bad enough, but increasingly we're going to be receiving calls from robots.
Yes.
Is the final output of the decision decomposition suitable to inform script design?
Yeah, it is. The script design can be a little tricky, but we certainly have folks who've built decision models to do script design. I would say that probably more likely is that you would identify a whole set of decisions that fed the script design. What kind of customer are you? What kind of response do you want? What kind of, there would be a set of things, and then that last layer you might do in a more traditional, in a more sort of channel-specific programming style that was more reflective of how that worked. So I would expect more to see that there were a set of decisions that fed into whatever that design paradigm was.
But out of the model, is there finally some XML-ish sort of?
Yeah, there's an XML format for it, which is interchangeable. What we mostly see people doing is, for each node in the model, either writing a set of business rules or building an analytic. Either a visual analytic if it's a manual decision, or a predictive analytic if it's an automated decision. So you'll see those nodes, and then there'll be 10 rules behind this one, there'll be 20 rules behind that one, there'll be an analytic behind that one. And what we do with the models is simply link them to the implementations. So if you remember, there was an implementation component piece, and so you can see these are the bits of implementation logic I have in my portfolio that implement this decision making. Then the model just shows how they're orchestrated together. All right, I want to be respectful of the time, so I'm just going to wrap up with my last couple of wrap-up points. So we set out to set 3 challenges. We said we had to clearly specify what our decision-making needs were if we were going to meet them. We had to do it in a way that would engage everybody. And we had to make sure that when we were done, we knew how we were going to deploy this. And hopefully, we've done enough demonstrating and talking today to show you that you can dramatically clarify the business requirements, the business needs, the business understanding you need for your business intelligence projects. That you can do this in a way where not only is everybody able to share the model, but you can have business analysts actually build these models. And if you're familiar with the BABOK, the Business Analyst Body of Knowledge, decision modeling is in the new BABOK, precisely because of that. And then lastly, because we know what objectives it meets, what processes it belongs to, what systems it impacts, we can see how we're going to deploy it. Thank you for giving up your evening. There's lots more on our website. My books, obviously, you're free to buy them, and buy your friends their great Christmas gifts. If you want to know about the software, there's a free version you can sign up for at decisionsfirst.com. And my email address, Twitter handle, everything else on the board. I will happily send the PDF to anyone who's taken a photo. So feel free. And if you want to link up with me on LinkedIn, please do so. If you can tell me where you met me, that always helps, because I speak periodically and I get these invites and I have to admit that I don't know who the person is, and they're like, oh, I had a long conversation with you at such and such an event. That was embarrassing. And with that, I'm done.